today we're going to look at discrete random variables. So the concept of a discrete random variable, and particularly finding expectation from discrete random variable. So let's start off with this problem. I'd like to have a go for yourself now, as far as you can. We're going to roll 2 cubical dice and add the values together, and then what is the probability of rolling a total of 5? Have a go at solving this problem. I'll give you about 4 or 5 minutes. Should take 3. We need to find the probability. You're going to start off in part A with an outcomes diagram. So with a cubical dice, we can get a 1, 2, 3, 4, 5, and 6. We can get a 1, 2, 3, 4, 5, or 6. If we add these together, we get 2. 1 and 2 gives 3, 1 and 3 gives 4, 1 and 4 gives 5, 1 and 5 gives 6, 1 and 6 gives 7. You see a pattern, 2, 3, 4, 5, 6. So 1 and 2 is 3, it's going to be 4, 5, 6, 7, 8. This one's going to be 4, 5, 6, 7, 8, 9. This one's going to be 5, 6, 7, 8, 9, 10. Then we've got 6, 7, 8, 9, 10, 11. Lastly, we go 7, 8, 9, 10, 11, 12. This is called an outcomes diagram. And this, together with tree diagrams, are the best diagrams for solving simple probability problems. I had it on the board at the beginning when the other students arrived. So we've got a 5 here in these 4 locations. This is 6 by 6, so there's a total of 36 possible outcomes. So the probability that x is equal to 5 is equal to 4 out of 36. 1 out of 9. What is the discrete random variable x? Discuss with the person next to you. What is the discrete random variable next? X.
The discrete random variable.
What is the discrete random variable x? What is the discrete random variable x?
It's the expected result of 2 trials for the same. I don't know.
Just leave off the word expected. It's the result of rolling 2 dice. So x is the total value on 2 dice. So B. What we do for this is we need to get a table of all the values for x. So x here is a capital X. So if we have a lowercase x, this is a particular instance of x. So I'll just draw a table. The possible values that x can have. What's the lowest possible value that x can have?
2.
2. So x can be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we can say for a discrete probability table, what's the probability that x, which is the total value of the 2 dice, is equal to x, which would be 2, 3, 4, and 5. So capital X is the entire event. Lowercase x is a specific value. So what is the probability that the total value of the 2 dice is equal to 2?
2 dice. Must be 1 out of 36.
1 out of 36. 1 out of 36. What is the probability that the total value on the 2 dice is equal to 3? 2 out of 36. Don't simplify these ones. Usually when you're working with these type of qualities and you're adding them together, having a common base makes things a lot easier. So don't bother to necessarily simplify. What about for 4? 5. We did. 6. 7. 8. Starts getting less again at that point, doesn't it? Starts getting narrower again. This is the longest diagonal there. This is our longest diagonal. 8. It's one less every time now from this point. So this one's going to be 4 out of 36, 3 out of 36, 2 out of 36, 1 out of 36. Get your calculator now and add up all of those probabilities. What are we going to get? Get your calculator and add up all of those probabilities. Celine, you have to bring a calculator to class. Have to bring a calculator to class. You got your calculator?
36.
But you divided it.
1 by 36. 1. Sorry.
You're very late.
Sorry, I was asleep.
Okay. So this is a key concept. Watch this one. Key concept. When you add them all up, what do you get? 1. Why do we get 1? Let me go on, go. You'll get this one.
It's a combination of all possibilities.
Yeah. Correct. Let me try some other phrases.
The whole probability is 1.
Why?
It's all probability.
Why? When you roll 2 dice, you have to get one of these numbers. When you roll 2 dice, you have to get an outcome. You can't not get an outcome, and these are all the possible outcomes. If you had 1, x equal to 1 or 13 or any other number, the probability is 0. You have to get an outcome from this. So this is a discrete random probability. And one of the key concepts is all values always add up to 1. Because something has to happen. Okay. Let's do C.
So the answer for number B was 1.
Yeah. No, it wasn't an answer. That was an add-on question. The answer number B was the table.
Oh.
I then wanted to move that towards the concept.
Oh,
Okay. So the answer to B is find the probability distribution, and that's the table.
yeah.
That's what B is. At that point, I wanted to introduce the concept.
If we have to draw a table sometimes to answer a question.
Yeah. Typically, you just fill in one value in the table that's given, an empty value. It's the usual question. All right, finding the expected value. I'm just going to show you how to do this. So it's a bit dull for this table that we've got. So we're going to use this formula. So the expectation, when you roll, what is the expectation? The expectation is the mean value. What would be the mean value of this data set? Let's do the calculation. So in this data set, we can see what the mean value is if you have some sort of understanding. What's the mean value going to be? 7. The mean value is going to be 7 because it's a symmetrical distribution. So the mean is 7, the mode is 7, the median is 7. This is such a symmetrical distribution, everything's in the center. But I'll show you the calculation and we'll do the calculation because it is tricky to do. If the probability distribution is not symmetrical, you need to do this calculation. I'm going to practice it a little bit. So just going back to the formula. So the expectation of the event is given by the sum of of each x value times the probability of each x value. Looks more complicated than it is. This is the expectation of the event x is the sum, and this is each x value. That's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each value times, and then the probability of each value. This is the event, and this is the expectation. Sorry, it's an M, the sum. So to do this calculation, we are going to need the expectation of event x is equal to, and we're adding them all up. So we've got, the first x value is 2, and that was 1 over 36. The next x value was 3, and that was 2 over 36. And we just keep adding them. What's the next term in this series? What's the next term in the series? 4 times 3 over 36. What's the next term? Somebody different.
5 over 4, 36.
Sorry?
Over 4 over 36.
Times 4 over 36. What's the next term in the sequence? Somebody else. Everybody's going to answer one. Come on. Vivian.
6 over 5.
6 times
5 over 36.
5 over 36. What's the next term in the sequence? Somebody else? Over here. Is that Maria?
7 times 6 over 36.
What's the next term in the sequence?
8 times 5 over 36.
8 times 5 over 36. What's the next term in the sequence? Ray? Celine?
7 times 3 over 36.
All right. We need to be able to type that into our calculator. That's a lot of typing. It looks super easy, but you'll get it wrong. We can often simplify this. Notice we have a common denominator in everything. So I could factor out 1 over 36. If I take 1 over 36 out of each term, take 1 out of 36, first term is 2 times 1. If I take 1 over 36 out of the second one, the second term is 3 times 2. What will the third term be? Nikki?
4 times 3.
4 times 3. What will the next term be?
5 times
5 times 4. The next term?
6 times 5.
6 times 5. And I can't be bothered writing anymore, so I'll go dot, 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 11 times 2. But you basically get it. You can use the ellipsis like this if you're writing out a long expression like that one, where you see the progression. You have to show the first 3 terms and the last term. You have to show the first 3 terms at least and the last term, so we see how it progresses. And if it's a very repetitive pattern, it's quite obvious. You go dot, 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 like that. All right, type that into your calculator now, see if you get it successful. The answer should be 7. So it's going to be backwards to the shop. Are you charging it plenty of time and then there's no charge in it when you unplug it? Yeah, very, very common. I got about 5 kids in my grade 9 class with this problem. I think it's caused by these calculators being stored in a warehouse over the summer in Dubai. And this just particularly fact, the sun was so hot, they're only supposed to be at 40 degrees. They leave them in a warehouse for 2 months, temperature over 40, battery through it. It shouldn't be failing like this. I've worked with these in other countries, and I've never had a problem.
Do you have an example, like or
If you have it plugged in, it will work well.
yeah, examples.
You can plug it in. What you should really do is, if you can buy it in the US, if you visit a cooler country, buy it there.
Yeah, the same thing happened with me. I want my favorite package.
Yeah, I think they've been stored in warehouses over the summer without air conditioning, and the batteries have been fine.
Because it's my fourth one. Every time I charge it, like it's good for like maybe a week.
Yeah. Oh, that's not so bad. That's normal.
No, like it's good for a week, and then once I charge it again, it won't turn on ever again.
Yeah. All right. So let me move on with this one. You should on your calculator get 7. Should on. Okay. Let's move on a little bit. Show that the function given here defines a discrete probability distribution by constructing a table of values. All right. So we've got the letter T. What values can T have? 3. What does this symbol mean? What does this symbol mean? Gotta get used to reading these symbols. Let me hear it better.
T is a number of whole
T is an integer. T is an integer. So it can't be 3.1, 3.2, and so on. So it's discrete. So we've got 4, 5, 6, and 7. And then we've got probability. Well, let's just do f of t to begin with. We've got f of t. What is, if we put 3 into this, what value will we get?
One over 15.
So if we put in 3 here, we've got 3 minus 2, which is 1. We've got 1 over 15. What about 4? 2 over 15? 5?
3 over 15.
Somebody else, the next one?
4 over 15.
The next one?
5.
So how can we prove that this is a discrete probability distribution? What's the main concept we've learned today? So it has to add up to 1. So how can we show that this is a discrete? We don't want the expectation.
Because if we add all of the probabilities, then we get 1.
Yeah. So if we want to show that this is a discrete probability distribution, we want 1 over 15, 1 plus 2 plus 3 plus 4 plus 5. What does this equal? You might not need your calculator for that.
15 over 15.
Yeah. When you're adding these type of expressions, look for easy picks. 4 and 1, 5. 3 and 2, 5. 5 plus 5 plus 5. We've got 15 over 15, which equals 1, which implies that f of t defines a discrete probability distribution.
So as long as it adds up to 1, it can be defined as a discrete probability.
Yeah. Or you can make a function, sometimes a piecewise function. So for instance, this table here, you could make a piecewise function that would go for this. If you define the function in 2 halves like this, you make a piecewise function that something like n minus 1 over 36 would define that bit. And then here you have to get a little bit tricky because you have to make it go down. you can use a linear function to describe that pattern there. There's some questions in the homework on that. So a fair cubical die and a fair tetrahedral die. How many sides does a tetrahedron have?
Oh, 4. It's a D4, right?
4. Tetrahedron. Imagine a dice made of a triangle instead of a square. Here we go. Tetrahedron. Tetrahedron.
D4.
We've got one side that we can't see at the back there yet. So, a fair cubical dice and a fair tetrahedral die are thrown. Discrete random variable S is defined as the sum of the numbers of the two dice. Construct a probability distribution of S. Have a go at this now. I'll give you a minute or two to try this exercise. Okay, I'm just going to make my table while you guys continue working.
Oh, that's S. Given that S is larger than 2,
S is at so 6 and below.
oh wait, it's lower or equal to, no, it's not that number than 2, it's going to be 14.
Yeah, it's 14.
I'm back. It should be 14. Should we look at the whole number?
No, yeah. Because it's still that to military.
Because you're limiting yourself to larger than 2.
No, aren't you?
No,
Yeah,
5 probability that
I think it's so So that probably the second one. So then you just do this. They were given that
it's
one.
larger. It's relatively
All right, let's have a look. So firstly, we need the probability that S is greater than 2. So probably the smart thing to do, you're not going to add up. What it wants you to do would be to add up all of these probabilities. That would be foolish, because if you notice I'm only missing 1. Why not just take this probability and take it from 1? So the probability that S is is greater than 2 is equal to 1 minus the probability that S equals 2. So it's 1 minus 1 over 24, 23 over 24. Complementary probability. 2. Probability that S is at most 6. So that's the probability that S is less than or equal to 6. At most 6. Less than or equal to 6. So which ones are we adding up this time? We want these ones. We want this. This is less than or equal to 6. So we've got 1, 3, 6, 10, 14. 14 over 24. I'm going to simplify that one. 7 over 12. And then 3. We've got the probability that S is less than or equal to 6, given S is greater than 2. So there's a couple of ways we can do it. We've got this, we want the probability that S is less than or equal to 6, but we already know that says it out of a total of these values. So out of a total of these values, where does it intersect? Where does it intersect? Well, it intersects on these on 3, 4, 5, and 6. So if it intersects on 3, 4, 5, and 6, that is if it intersects on 3, 4, 5, and 6, that is 5, 9, 13. So we have 13 over 24, out of a total of 23 over 24. We have a common denominator in both those fractions, so it simplifies to 13 over 23. Okay, last question. Have a go at this one for yourself now. Okay, so we've got the discrete random variable with an expected value of 3.7, and we've got this table. We have to find P and Q. We've got 2 unknowns, so we're going to need 2 equations. What equations could we create from this information? What's the main concept I've introduced today?
Expected value, which is
No. What's the main concept I've introduced today?
Everything equals to 1.
Everything equals to 1. What equation can I make with that?
I'm not sure, but I would P plus 0.3 plus Q plus 0.4 equals 1.
Excellent. There's our first. Now the expected value. How do we calculate the expected value?
It's going to be 2 multiplied by P plus 3 multiplied by 0.3, 0.3 plus 4 multiplied by Q plus 5 multiplied by 0.4.
You know,
What's that equal to?
That's going to be 3.7.
That's going to be 3.7. If you form an equation system and solve it on your calculator, you need to show the equation system. So just on your exam style technique here for a minute. Exam style technique. I've seen sometimes people solve an equation system. There's one equation on the left, there's one equation somewhere over here down on the right, and you don't know that equation system is being used. You must line your 2 equations up, one on top of the other, and connect them with a single curly bracket like this.
so this is something like what's going to be on the minor.
Don't give away my secrets. Okay, so this is how an equation system should be formed, and then we can just simply type it on our calculator and write the answers down. So let's have a go at typing that one in now. Let me shrink that over here. A little smaller. Gonna get really lazy with it today. Have a go at typing it in or follow me through. So menu, algebra, solve a system of linear equations. I'm gonna have x as p as, I'm gonna have p as x and q as y. I prefer to switch to x and y. If you want to continue writing in p and q, you can do this. Actually, I'm doing it now, so I'm doing it. So p, comma, q. So if you want to write in terms of p and q, change what is written there, and now we can just write it in terms of p and q. So p plus 0.3 plus q plus 0.4 equals 1. 2p plus 3 times 0.3 plus 4q plus 5 times 0.4 equals 3.7. I'm just going to double check that I've entered it right. That looks good. That looks good. Press enter. I get my two answers, 0.2 and 0.1. So, which one's which? Where's my calculator again? 0.2 is p. So this implies p equals 0.2, q equals 0.1. All right, listen to my table. 0.1, 0.2. This is part A. Part B. Given that the outcome is greater than 2, find the probability that it is less than 5. So we want the probability that x is less than 5 given x is greater than 2. Given the outcome is greater than 2, find the probability that it is less than 5. So greater than 2, given that it is greater than 2, so that means this is not in my probability distribution. Given that it's greater than 2, what is the probability that it is less than 5? So I want 0.3 plus 0.1 as a total of 0.3 plus 0.1 plus 0.4. I want these ones out of a total of all 3. Given that it's greater than 2 means that this part of the table is removed. Given that it's greater than 2, it's removed. We want the green part out of a total of the whole bit that's left.
Well, why would the denominator have the 5 in it as well?
Because given that it's greater than 2, I remove, this is the entire table. So out of a total of all of this that's left, once the grey bit has been removed, how much of it is green? Gonna have to simplify that a little bit. We've got, we've got 1 plus 3, so 4. We've got 4, 8. Okay, that is it for today. Let me go through the homework for you. Let me stop the video.